All right, so we saw the graph of the, we talked about this a little bit before, we saw the graph of the old one where the water comes in and falls all the way to the bottom, like to the table, and starts to fill it from there, right? But then if we turn the water at the same time in this new one, it starts right there, right? It hits at the, at the same time that this is hitting the bottom, this is hitting right here. So what did we say was different about the two graphs? Hayden?
One's higher off the ground. Because that little line right there.
Is that so the graph?
Yeah,
You're
so
telling me about the cup, but what about the graph?
like, if the old one goes straight across, then
Okay,
that
so
one would go.
We have that kind of established, that it goes straight, just like this, constant, the height is constantly changing at the same rate. But
Then
this one,
the new one would be a little higher than that one and with the same line.
what's the same about it? Something's the same.
Area.
Same area?
Still straight.
Still straight, but all lines are, okay, I mean, yeah.
Parallel.
Straight, okay, parallel, good. Right? They're filling up at the same rate, the height is changing at the same rate. Okay? Carter? So they go up, they're filling up at the same rate, the height is changing at the same rate, right? If in 1 second the water on this one goes from here to there, well, this one's gonna go from here, not to here, right? But it's gonna go up just as much, just from the bottom of that cup. Does that make sense?
Yes.
The height is gonna increase, but over the same amount of time, this one is going to be higher than this one. Okay, does that all make sense? All right. So we said this, right?
Mm-hmm.
We'll read that. All right. It starts out higher on the y-axis. So we're going to translate what we've learned about rates, okay? Rates. And here, we were talking about the rate that the height increases. The rate that the height goes up. We're going to use that, we're going to translate that into equations and graphs. So let's try this, some numerical, some specific numbers plugged in here. Can you write an equation that will, like y equals something, that will tell me what the height is after x seconds? Right, after x seconds. Could you write an equation that if I plugged in x, like I plugged in 5 seconds, it would tell me how high the water is, what level the water is at? Who thinks that they can throw that out there? An equation that would tell us how high the water is after x seconds. Kaden?
Y equals 2 times x
2 times x. Is that it?
plus 7.
Plus 7. Why plus 7?
Because 7's already gone.
Yeah, it already, like at the very instant that it hits the bottom of the cup, it's already at 7 inches high, right? At 0 seconds, it's 7 inches high. Okay. Who agrees with Kaden? Okay, can we test it? See if it seems to make sense?
Yeah.
Yeah.
Okay. How can we test it a little bit and see if it makes sense? Test it against their condition. Plug something in,
Yeah.
see if it makes sense. All right. So what can we plug in?
0.
0. 2 times 0 plus 7. Okay, so put in 0, 0 what?
7 seconds.
Seconds, 0 seconds. And we got out 7 what?
Inches.
Is that true? At 0 seconds is it 7 inches high?
Uh-huh.
Let's try another one like 2. Let's try 2. So 2 times 2 plus 7. And we get 4 inches plus 7. So it's at 11. Do you agree? Would it be at 11 inches high after a couple seconds?
Yeah.
Oh,
After
yeah.
2.
Here we go. What did I say?
After 2 seconds.
After 2 seconds? What did I say?
After a couple seconds.
What's a couple?
2.
3.
Here's one of my pet peeves. A
Couple.
couple.
2.
2.
Couple.
Oh yeah, like
Couple. If you're a part of a couple, you're not a part of 3 people. You're
That's
a part
a
of
few,
2.
right?
A few, mine.
A few,
Few
yeah.
is vague. A couple has very specific meaning. Anyway, a couple seconds is 2 seconds exactly, no more, no less. always 2. Couple is 2. 2 times 2 is 4. So it increases a total of 4 inches from the original 7. So it's at 11 inches. Right? So we plug in 2 seconds, we get 11 inches as the height. Right? Okay, the next one is for each of you individually. See if you can recreate what Ada did with this next example. Here.
I know what it is, I think.
What do you got?
Y equals 3x plus 5.
Who agrees with what Robert's put down there? Okay, sounds like a lot of people would agree.
Oh, yeah, I do.
I agree as well, because let's think about what's going to happen here. We're going to get 3 inches per second times x. What is x measured in?
The number of
Number of seconds. Plus 5. 5 what?
inches.
Inches, right? We start at 5 inches. You can think of that as the beginning point. It starts at 5 inches and then adds, right? Just adds on from there. We just get more and more height after the very beginning. So if I plug in 1 second or 2 seconds or 3 seconds, that's going to multiply by the 3 inches that I gain every second and tell me how much to add on to the 5 inches I started with. Okay? Last one of this kind of nice numbers. Okay, let's write this down in our notes. I bet it won't take very long. Brandon?
Y equals 5x plus 3.5 inches.
Minus?
Oh, no, well,
Maybe if we write it in this order, those are going to be the exact same thing. Right? Think of it as we start at 3.5 inches. Right? Does it go up from there?
Uh-huh.
Does it go down?
Goes up.
It goes up, right? We fill it with water, the height goes up. So it goes up, it gets bigger, it increases by how much? 5 inches. Right? Every second. So 5 times the number of seconds. If it's going for 1 second, it goes up 5 inches. It goes for 2 seconds, it goes up 10 inches. It goes up 3 seconds, it goes up 15 inches. You know, that's added to the original 3.5 inches. Let's jump back a couple here. Let's look at the graph. Okay? So this right here, this is the origin. 0, 0. 0 seconds, right? 0 seconds, 0 inches. So it starts, does it start out down here? Does the graph start out down here? Where does it start?
Right after the bottom of the glass.
Bottom of the glass, which is how high?
This is 7 inches.
7 inches, right? It starts right there at 7 inches. Okay, and there's a tick mark right there that's probably impossible for you guys to see, but there it is. So, what's that?
Yeah,
I can see it.
Oh, you can see it, okay.
Yep.
wait, the one I
Pretty good.
The one I made, you can see, this one's probably pretty hard to see. Hard for me to see. I'm right here. Exactly, it's right there. Anyway, let's say that tick mark represents 1 second. Okay, so in 1 second, look at the scenario, in 1 second, what's going to happen to the water?
It's going to go up
Yeah.
2 more.
2 more inches,
4
right?
inches.
So 1 second goes by, and it increases by 2 inches. Now this is 7 inches. We'll try to kind of make this to scale, so maybe like that much. Right? You're gonna try to establish a pattern here. So another second goes by. Here's the second tick mark. Let's call that 2 seconds. What happens after that next second? What happens in that 1 more second? Goes up 2 more. Okay, so it's gonna go up, let's call that 2 more. Okay, in those 2 seconds, it's gone up a total of 4 inches, right? Every second it goes up 2 inches. Jackson?
Would it have be higher than that because 7 and then that's kind of there and then 1 second it goes up 2 inches and after 2 seconds. Oh wait, then
You got it?
I think yes.
Okay. Well, if this is 7 and this goes up 2, then that's going to be 9, right? And if it goes up 2 more, that'll be 11. And that's what we found when we plugged 2 directly into the equation. Okay, let's go to second number 3. That's 1 second later. 1 second later, what happens to the water?
goes up 2
Goes up 2 inches. You start to see this pattern I'm trying to get you to see?
Yep.
Every time a second goes by, what happens?
It goes
Rises
up
up
2 inches.
Okay, over 1 second and up 2 inches, over 1 second and up 2 inches, right? And all the way in between, like half an inch, like half a second goes by, it goes up 1 inch, right? So there's a point right there. And a quarter of a second goes by, it goes up a half an inch. Right? Anything in between. So I could plot all those points. When I'm done plotting all those points, what do I get? A straight line. Right? That's where a straight line comes from. It's that steady pattern of over 1 and up to, over 1 and up to. Okay. So that slantiness, okay, we call the slope of the line. The line has a slope. The slope is a measure of just kind of how slanted the line is. Okay? When we're talking about the actual water stuff, we call that the rate of change. Okay? The rate that the height increases. Okay? There's lots of different rates: miles per hour, meters per second, dollars per day, dollars per year, inches per second, whatever. Anything that is one thing per another is a rate. Okay? So when we talk about the water itself, like the actual physical object, it's a rate. It's a rate of change. When we graph it, and you look at that rate of change on the graph, it's called a slope. Rate of change, slope, okay? Essentially the same thing. The rate's talking about the object, the slope is talking about the line. Okay? And this slope is 2 inches per 1 second. So it's a slope of 2. Right? Okay. Let's talk about this one. It starts off at 5 inches, right? A second goes by.
Over 3 inches.
Very good. Goes up 3 inches, and that would be about that. Goes up 3 inches from there. Another second goes by, what happens?
3 inches.
3 more inches. Total of 6 inches, right? Increased on top of 5 inches. Another second goes by. Okay, I lost you. Another 3 inches. Okay? And everything in between and everything past that will follow that pattern. Okay? Even if we go down to like a little tiny, right, or like this, it goes over 1 and up 3, but if we just split it up into the tiniest little millisecond, okay, it would still be a ratio of 1 to 3. Like 1/1000th of a second, it's going to go up 3 1/1000ths of an inch. So the slope on this line is 3 inches per 1 second. Okay, or on the graph, like 3 y's for 1 x. Okay? I'm trying to take you a little bit by about scaffolding. I'm taking you from what you know to something you might not necessarily know. Right? So I'm adding on this little bit, 3 y's for every 1 x. Okay? In the physical world, when we're talking about the actual water and the height that it has, it's 3 inches per second. The graph has a slope of 3 over 1. This last guy, really quick. 1 second goes by. After it starts at 3.5 inches, 1 second goes by, and what happens?
Goes up 5 inches.
It goes up 5 inches. It's actually going to look maybe something like that. It's going to go up 5 inches. Right? It's at 8.5 inches. 1 more second goes by, and what happens then?
8.5 inches.
What's that? It goes up how much?
5 inches.
5 inches. Right? It goes up 5 inches from there, and so on. Another second goes by, it goes up another 5 inches. And it looks like, from this drawing, that maybe it would start overflowing pretty quickly. So it's filling up really fast. So we're going over 1. We're going up 5. So for every 5 y's, we go over 1 x. So for every 1 x that we go over, we go up 5 y's. Now, let's say it starts at 6 inches and goes up at a rate of, now this rate is a little bit off. It's not 4 inches per second, it's 4 inches every 3 seconds. So can we write an equation that would tell us how high the water is after x seconds, right? Let's give that a try. Now when I plug in a value for the time, right, x seconds later, it should tell me how high the water is. Let's make this easy, okay? At 0 seconds, how high will it be?
0.
Yeah,
6 inches.
6 inches, right, 6 inches.
Oh,
Starts at 6, it just goes up from there, right? Can anybody tell me its height at any other time?
yeah, I got it. 0.75 for 1 second.
It's already at 6, how could it be a 0.75 at 1 second?
No, 6.75 inches at 1 second.
And how did you get that?
Divided 4 divided by 3.
If you divided 3 by 4.
I divided 4.
Yes.
Before, that would be 18.
What would be 18?
So, wait, why? Right? It,
When would it be 18?
oh.
After 3 seconds?
Yeah.
Okay, after 3 seconds, 1, 2, 3 seconds. Who agrees it would be at 18 inches?
Oh,
How far does it go up and in 3 seconds?
4 inches.
4 inches.
So,
Wait,
well,
yeah.
it starts at 6, and 3 seconds later, if it goes up 4 inches from there, where will it be?
12.
So it goes up 4 inches. 1, 2, 3, 4 inches. It started at 6, so it should be at
10.
10, not 18, not 12. Right? So 3 seconds later, it should be at 10 inches because 3 seconds later, it goes up 4 inches. 3 seconds later, how high will it be?
14.
In 3 seconds, how high will it go?
It'll go 4 inches.
4 more inches. 1, 2, 3, 4 inches. So it should be at
14.
14. And 3 seconds later,
It would be
4 more.
18.
at 18. Okay, 3 seconds later,
4 more.
4 more. 22. Okay, so that's how our function needs to work when we write it. When we plug in 3, it should go up to 10. When we plug in 6, it should go up to 14 and so on. How do you make that work? How about this? Notice in all of these, see how the rate comes right down into our equation times x. The rate, 3 inches per second, comes right down into our equation times x. The rate of 2 inches per second, right down there in our equation, 2 times x. Okay? So, let's try that with this new one. 4 inches per every 3 seconds, 4 inches per every 3 seconds times seconds plus 6. See. Let's try plugging in 3 seconds. Right, after 3 seconds, how many inches should be added on?
6. No.
4 inches.
4 more inches, right? We should be at 10 inches. But what's 4/3 times 3 over 1?
12 over 3.
Okay, what's 12 divided by 3? 4. And remember, 3 divides 3, it just leaves a 1, right? So that's 4. 4 plus 6?
10.
4/3 x plus 6. Let's try 6 seconds. Y equals 4/3 times 6 seconds plus 6. What's 4/3 times 6 over 1?
8 over 1.
8 over 1. And 3 divides 6, that leaves 2. 4 times 2 is 8. Plus 6 is
14.
14, just like it ought to be, right? 14 after 6 seconds. Okay, you give it a try. Give it another try with this scenario. It starts off at 4.25 inches, and every 5 seconds it goes up 6 inches. Who's got an equation I think will work? Carter?
Everyone.
Robert?
I did y equals 6/5x plus 425.
Okay. I think that makes a lot of sense. This is like the fifth one that we've done, right? They all have this plus 4.25 or plus 7 or plus 5 or however many inches it starts at, the starting point, right? So it starts here at 0 seconds. If we don't let any time pass, it'll start at 4.25. Plug in 0 for x starts at 4.25. Okay. Then we start plugging in values for x, right? The easiest thing to do right now is to think about what happens in, well, what happens in 1 second, 2 seconds, 3 seconds? How many seconds would we like to go with? 5 seconds would make it easy, right? Because in 5 seconds, how many inches is it going to go up?
30.
6 inches. Just remember that second drawer down. On that right cabinet, second drawer down. Or maybe third. Try third. Third drawer down.
Nope,
Okay, try second.
doesn't look like
What's
it.
going on? Alright, so 5 seconds later it should go up 6 inches, right? It starts at 4.25 right there. 5 seconds later, let's call this 2 seconds, 4 seconds. This is 5 seconds. After 5 seconds, it should go up how many more inches again?
6.
6 more inches, and put it somewhere up in there. 6 more inches. That should put us at 10.25 inches, right?
Yep.
Let's take a look. If we plug 5 seconds into the equation we just wrote, then, well, what's 6/5 times 5 over 1?
30.
Over
1.
5. 30 over 5. What's 30 divided by 5?
6.
6, right? 5 divides 5, that leaves a 1. 6 times 1 is 6 plus 4.25. That's 10.25. Another 5 seconds go by, it goes up how many more inches?
6 inches.
You started to get it, I think. There you go, that's a total of 10 seconds. That's 5 seconds later, it goes up another 6 inches. And connecting in a nice straight line. That's what it looks. It's going to be y equals the rate of change, right? The rate of change times x plus 9. 9, as you can think of it as the starting point, starts out at 9. Okay. And every, how many seconds?
8.
Every 8 seconds, what happens?
3 inches goes
3
around.
inches up. So 8 inches go by, let's call this, or sorry, 8 seconds go by, let's call this 4 seconds. 8 seconds. 8 seconds go by, we go up another 3 inches, that'd be right about there. 8 more seconds go by, and what happens?
We go up 3.
Up 3 more inches. And on and on and on. Every time we move over in the seconds axis, right, in the seconds direction, 8 seconds in the future, the height goes up 3 inches. Okay? So this over 8, up 3 is called our slope. Again, it's called the slope of our line. It's also the rate of change of the height, in this case. Rate of change of the height. So you'll notice that on the graph, we've done this before, it just hasn't really been formalized yet. We start out at 9 inches, right? Which is something we've done before when we graphed lines, right? We plugged in, at first we plugged in what?
0.
0, right? We like to plug in 0, we get that number right there. That's where it starts off. Right? Then we like to move over how much in this case? We like to go over to 8. We like to move to the right 8, right? So that when we plug in 8 for x, cancels that out, and we have 3 left over. Move up 3. We can also, instead of having to actually plug in that number for x, we can see that that rate of change translates to a slope where we just move over 8 seconds and go up 3 inches. Over 8 inches, up 3. Like no plugging in of numbers required. You see what I'm saying? Just using a nice little pattern there. Okay. So if we were to say, we had this equation y equals 5 thirds x plus 2. Okay. Look at the graph of that. This would be like a glass that starts off at how many inches? At 2 inches, right? It's 2 inches off of the table. Starts off at 2. That's the 0.02. You know that. It's only 0 for x. We get 2. Okay. And I know that 3 seconds later, what happens?
Is that 5 inches?
Goes up 5 inches. Over 3 and up 5. I didn't even have to plug anything into the function. I didn't have to figure out what the y value was, because I know that 3 seconds later, it'll be up 5 inches. So I can just go over 3 and up 5, and I have another point. It's going to be a line. 2 points are enough for a line. There we go. We can throw it the other direction too. We've got the whole line for all eternity in both directions. Okay. Following that, what do we call this on the line?
Slope.
The slope. Good, slope. The slope of the line is that we go to the right 3 and up 5. To the right 3 and up 5. To the right 3 and up 5. Yes? All right, you try it. Oh, wait, let's not do that yet. Let me give you this equation. Y equals 5 sevenths x plus 4. Okay. Try me a quick graph of that function. Okay, so a reminder, like because of these last 7 or 8 examples we've done, we are taking advantage of a pattern. We can see, we can plug in things for x, but we can follow a pattern and say that I know that this guy is going to start out at 4, right? It's like a cup that's 4 inches off the table, right? Like 4 inches off the table. Starts off at 4 inches. And, okay, then I'm going to go over how many seconds?
4. More than 7.
7 seconds. 7 seconds later, 1, 2, 3, 4, 5, 6, 7. 7 seconds later, what's going to happen? Go up 5. There we go. 1, 2, 3, 4, 5 seconds. 7 seconds later, 5 inches are added to the height of the water. Now we have 2 points. 2 points are enough for a line. Here's our line. There we go.
Do we get extra credit points for this? Because we've been really good.
Then, right.
We haven't asked us to do it once.
That's like average where you don't make lots of money.
That's a new record.
It is an accomplishment.
We're positive.
You are positive.
We haven't even gotten extra.
You are doing well. I appreciate it. I would like to see more people like taking notes, paying attention, right? Just because we're not talking doesn't mean that as a class we're like moving forward. Those people who are paying attention are taking notes, seeing improvement. So it should all be like that. One more little graph here. Just see. Yeah, here. Put negative there. Negative.
What's wrong?
3 plus x
Oh no,
plus 1.
this is hard.
Actually, let's make it like plus
4.
7. Kind of a bigger number, okay? All right. Now we've had this before. We've had negatives in front of the x before, okay? But if we make it, try and fit this situation of the container with water in it, what's going on with this container of water?
It has a hole in it.
Good, it has a hole in it. It is emptying of water. It is not filling up with water. As time goes by, the water's going down, right? It's got a hole in it. So, Well, that's 0 seconds. How many inches is it?
Seven.
It's 7. It starts at 7. It starts out filled up a little bit. Let's call that 7.
It's a lot of space between 0 and 7.
Sure. And then, how many seconds later?
4.
4 seconds later. What happens?
You lose 3.
You lose 3 inches. So it goes down, let's call this 3 inches.
3. Bam.
Now, how full is it?
That full.
How full is that? 4 inches, right? It's got 4 inches of water in it.
I told you.
Very cool. All right. It starts at 7, yes, and it goes down from there. It loses 1. That's where the 7 comes in. Don't forget about that. I mean, still keep in mind, if I plug in 0 to this function, what am I going to get? I'm going to get 7. Right? That's why we start up at 7. And if it's negative, it's going to be going down. Remember that we have this over this much, right, and up this much. And if that up is a negative number, actually up a negative amount means down, right? You go over that many seconds and up that many inches, maybe down if that's what the situation calls for. Or you go backwards in time 4 seconds and see the water level go up. Right? I go backwards in time 4 seconds, it goes up 3 inches. Very good class today. Thank you very much.